We'll work on application problems that result in systems of linear equations that we can solve. So working our way through school, Julie works 2 part-time jobs for a total of 25 hours per week. Job A pays $6 per hour, B pays $7.20 per hour. How many hours did she work at each job? The week she made $165.60. So we have to write down the 2 unknown variables, which is how many hours did she work at each job, right? So number of hours at job A, let's let that be X. And the number of hours at job B, let's let that be Y. And remember that the job A is $6 per hour, and job B pays $7.20 per hour. All right, so now we can write down our system, which is given by these totals. The total number of hours she worked was 25. So X plus Y should equal 25. And then the total amount of money she made, which should be 6X plus 720Y, that should total up to 165.60. So here's my system. And you can solve this any way you like. I think I'm going to go ahead and multiply both sides of this first equation by -6 so that I can eliminate the x's. So this side by -6 and this side by -6. When I do that, well, I'll go this way actually. It results in 2 equations. -6x minus 6y equals 25 times -6. What is that? -150, I think. Let me check. Yeah. And then we've got 6x plus 720y equals 165.60. So now when I add these 2 equations together, that'll eliminate the x's for me. 720y minus 6y is 120y. And then 165.60 minus 150 will be 1560. So 120y equals 1560. We can divide both sides by $1.20 or by 1.2 to get $15.60 divided by 120, 13. So y equals 13. So I can write that down now where I went and declared my variables. Y is 13, so we worked 13 hours at job B. And then I can use this equation, this first equation here, which says x plus y equals 25, using 13 for y. We get y is 12. Sorry, x is 12. So we worked 12 hours at job A. All right, so the method here, so make sure we know what our unknowns are. Look for totals in order to write down these equations, and then use whatever method you would like to solve those 2 equations. All right, let's look at another system of another application problem that results in a system of equations. This one involves 3 variables. The sum of 3 integers is 140. The sum of the first and the second exceeds the third by 100. And the third integer is 100 less than the first. Find the 3 integers. So first of all, what's an integer? We have to know that. An integer is like a whole number or a negative whole number. So that's what we're looking for. No fractions or decimals. We should declare our variables. let's say let x, y, and z be the 3 integers. Now let's use all of this information to write down some equations. The sum of the 3 integers is 140. So that tells me x plus y plus z equals 140. The sum of the first and second exceeds the third by 100. So the sum of the first and second, that's x plus y, it'll be equal to the third plus 100. So it exceeds the third by 100. It'll be like a third plus 100. And then the last equation, the third integer is 11 less than the first. So that's z is like the first integer minus 11. The third integer is 11 less than the first. So this is my system of 3 equations. So you can solve this in any number of ways. The way that I'd like to do is some combination of elimination and substitution. Because if I take a look at these 2 equations, if I subtract them, that'll get rid of both the x and the y, right? So let me go ahead and just look at equations 1 and 2 here. Focus on those. X plus y plus z equals 140. And the second equation, x plus y equals z minus 100, I actually want to put the z on the other side. So I'll subtract z from both sides. X plus y minus z equals 100. Okay. Now if I subtract these equations, that'll make this negative, this will be positive, and this will be negative. So it gets rid of the x's, gets rid of the y's, and z plus z, I get 2z equals 140 minus 100. That'll be 40. So dividing both sides by 2, z is 20. So this is just, I noticed that the x and the y is matched up in the first 2 equations, so I could get rid of them easily. And what I end up with is z equals 20. Now I can use this inside the second equation, or inside the third equation here. Z equals x minus 11. I can plug 20 in for z. Add 11 to both sides. Now I know what x is. And at this point, I can use either equation 1 or equation 2 to solve for y, because I know what x and z are. Let's go ahead and use, I'll use equation number 2, which is x plus y equals z plus 100. Let's go ahead and plug 31 in for x and 20 in for z. So I get 31 plus y equals 120. Let's go ahead and subtract 31 from both sides. We get y is 89. So now I know what the 3 integers are, and I can state that in my solution. The 3 integers are 20, 31, and 89. I didn't really have to put them in any order because the problem didn't specify any specific order. Okay? So I solved this method, or I solved this problem using substitution. This was what's called kind of like a sparse system, where like one step will easily eliminate a whole bunch of variables for you. Now, after you look at section 8.2, you might see that there's another method for solving this, this system, and I do want to go over that with you. That other method, so you can even come back to this after viewing section 8.2. We could use the matrix method. we're looking at this system of equations, making sure that the system is in standard form. So the first equation here is in standard form. X plus y plus z equals 140. The second equation, if I subtract z from both sides to get everything on the left, I get x plus y minus z equals 100. And this third equation, let me subtract x from both sides so I get all variables on the left. We get negative x, I don't have a y, and then plus z equals negative 11. So again, after you view the video for section 8.2, you learn about matrices. And you can put this system into a matrix. It's called an augmented matrix. It looks like this, where we use the coefficient of x and y and z, and then last put the number that those are equal to. So 1, 1, 1, 140. That represents the first equation. Here we have 1, 1, negative 1. 100, that represents the second equation. And negative 1 for x, 0 for y, 1 for z equals negative 11. That represents the third equation. So once I have my, this is called the augmented coefficient matrix, I can go ahead and plug this into my calculator and put it in reduced row echelon form. So here's what that looks like. Find the matrix button on your calculator. We'll go ahead and scroll over to edit. And we'll edit the matrix A. Let's make sure it's a 3 by 4 because we have 3 rows and 4 columns. So make sure it's 3 by 4, and you can edit those numbers by just typing in numbers and hitting enter. And then we'll type in all of those coefficients. So we've got 1, 1, 1, 140. That's the first equation. 1, 1, negative 1, 100. And then the last equation is given by negative 1, 0, 1, negative 11. Now that I have that in there, let's go ahead and exit out. And now I'd like to do a calculation with that. So I'll go to the matrix button one more time. I'll go over to math, and I will scroll down until I see RREF, which is the reduced row echelon form of the matrix. And then I'll go ahead and plop the matrix A right in there. And what I end up with is the reduced row echelon matrix, 1, 0, 0, 31, 0, 1, 0, 89, and 0, 0, 1, 20. And what this tells me is I've got this 3 equations, 1x plus 0y plus 0z equals 31. So x equals 31. The second equation here says y equals 89. And then 0, 0, 1, this is the coefficient of z. Z equals 20. So your 3 integers are 31, 89, and 20. So depending on your style, you may like one method better than the other, but they both work relatively quickly.